Good day to everybody. Thank you for joining us today. Welcome to this webinar Wednesday. Today we're going to have a look at unlocking the value of smart building data, and I'll hand over in a second to Nathan Brown, who is our host and moderator for today. So first, I would like to just take a moment to acknowledge the traditional owners of the land that I'm joining from. For me, that's the Turrbal and Yagara people up in Brisbane. We pay our respects to any owners past, present and emerging, and any participants here today. So today we're going to have a look at smart buildings, which, as we will dig into, are generating more data than ever before, from energy use to occupancy to air quality and system performance, but remain fragmented and siloed, and much of the data is underutilized, in our opinion. So we want to address the need for open and interoperable data standards within buildings. We want to have a look at what exists, what doesn't exist, and how cities and organizations can drive things forward without having to create their own systems due to any unenforceable or consistent standards or knowledge thereof. So for this conversation, I'm going to hand over to Nathan Brown. Nathan is the founder of BCA Engineers and is going to be able to share his extensive experience in the sector with us. And then he'll also position some of his thinking around this need for more collaboration around the development of specifications. So I'm going to hand over to Nathan, and sorry that it's brief, but I don't want to take up too much of everyone's time during lunch. And then Nathan will hand over to our speakers to do a quick intro. Thanks so much, Nathan.
Okay, thanks, Robin, for the intro. Just by way of background for myself, I went to university, did mechanical engineering a long time ago, started as a graduate engineer as mechanical engineer in heating, ventilation, air conditioning in 1995. And I've stayed in the industry since I graduated and I've worked at various companies, including big multinationals. I worked for AECOM, Oricon. And in 2008, I started my own business, BCA Engineers, with my business partner then, Patrick Campbell. Today, BCA Engineers is approximately 70 people, and we have offices in Malaysia, Singapore, and Melbourne, Adelaide, and Darwin. And some of my recent expertise or knowledge has come about by accident, where I developed a company called FireM, and that was basically having data connectors to fire alarm panels. And in that process, what I was doing is I was taking all different sorts of information, different connectors, Modbus, RST32, 485, taking whatever data we could out the panel, standardizing that data, and then we were then forwarding that data on into a data lake for then processing to front-end analytics. So it's simple now. Everyone's doing that now, but this is 10 years ago I started coming up with this. I'm no longer an owner of FireM. That was sold a few years ago, but I still actively am involved with that company, especially in regards to fire protection, fire safety data. More recently, I've also developed a smart fire extinguisher. So we actually digitize various inputs from the extinguisher, and then we collect that data and send that into the data lake as well. And with that, and also the fire alarm panels, there was a gaping need for standardizing data, because we've just come up with our own data protocols of what we collect and how we process that data. But there's a real need that we, across all different sectors and different inputs, that we need to have some standardized data so that we can then make it easier for business owners, managers, facilities managers like CBREs or JLL to then be able to just plug in, and it doesn't matter what the building is, they'll get exactly the same data streams and formatted exactly the same. So the real need that the real issues that we have right now, especially even in my own company, I have a whole bunch of building services engineers. I have electrical engineers, fire engineers, mechanical engineers, people who write BMS systems, etc. But no one is thinking about specifying what that data needs to be taken out of the system and put into a data lake. As an example, lift control panels, lift control systems. I haven't shown them on this diagram here, but lift controls are pretty well siloed. If we are then specifying the lift systems for a building, we should also be specifying, hey, we want this data from the lift control system as one-way data. And we want it in this format, and we want it to go into this data lake. So across all of these systems, including VMS systems, we also want to extract the data from the VMS system. We're into full interoperability here. We're not relying on having any particular company have ownership of the data for that building, and creating a data lake, or essentially a digital twin of that building. So there's three main components of what we're talking about here that we have to, which is our task force, that we need to try and work towards preparing technical specifications for what types of data, or how we're going to connect the data, what types of data, how that data is going to be transferred, and where that data is going to be stored. And then we've also got obviously the security of all of that process as well. It's quite a big task to tackle. And of course, there's lots of different people that are already involved in some of this, and a lot of people involved in it for their own interests. What we should be looking at here as a group is trying to look at what we can provide in terms of a data specification and process that will be fair to everyone. As an example, if we talked about emergency and exit lighting, okay, we've recently done some interface with Legrand. Now, Legrand's system for emergency and exit lighting produces completely different data sets to, say, Clevertronics. Clevertronics is probably somewhat more comprehensive in terms of the different types of data. What we will need to do for emergency lighting is to say, what are the core pieces of data that we need to get as a mandatory output from that system? What are the nice to haves? So if we're deciding that something is core, then we can go back to people like Legrand or whoever else is specifying, producing emergency exit lights, and say, we want this data. Okay, you're going to provide it as part of your system. Okay, so there's that part of that, and it's immense. And we've also have other data connectors, which could be from APIs or databases. So, for example, we could take weather feeds from the Bureau of Met in Australia as an example, as part of that data feed. What I'm really focusing on, though, for this forum and this group is mainly the active data, not the BIM model, not the static stuff, okay? This is a live data coming into the building. This data can be used for maintenance and the ongoing assessment of the building compliance, or even the performance of the building, okay? There already are some quite good data sets and processes for Revit modeling or the BIM stuff out there, but I'm proposing that we don't touch that as part of this technical group that we're assembling to look at this issue. Next slide, Robin. So we start talking about data connectors. They're probably the first step. What are we wanting? How are we going to connect all these different systems to collect the data? Okay, we need to specify that. We may not need to specify what the actual data connector is, but we may need to say we need to be able to get the data out somehow. I've just given a few examples of different types of data connectors in that slide, and there could be a whole bunch of different things. We also have standardized protocols like Modbus, BACnet, that sort of stuff, which is also available. We can potentially take Modbus and BACnet and have data converters that convert that data out of those systems into what we need for a data lake in our digital twin of our building. Now, next slide. Thanks, Robin. I've probably already talked about this. This is just talking about different types of data connectors, different systems. Maybe next slide. I'm talking about our focus here on the fire, but this could be anything. And we're not just talking about systems that already have pump controllers or lift control systems. Now we're talking about new types of sensors technology, like portable fire extinguishers, digital hydrants, digital hose reels, reading doors through LoRaWAN or whatever other technology that we're employing. So all of this data needs to be consistent. Doesn't matter if it's coming from a temperature sensor from a VMS system. It has to be similar to the temperature sensor coming from a, say, a LoRaWAN one-off temperature sensor. In terms of the building, it's still data. They may not be connected to each other, but it's still information that we want going into our data lake. Next item, thanks. This is just an example of our current, in my company anyway, and it's probably pretty similar in a lot of building services engineering companies. And here I'm addressing the guys who are specifying the buildings, okay? With the people like ARIPS and AECOMs and GHD, BC engineers, consulting engineers, okay? We as a group, we need to be providing a specification for data collection and how we're storing it, processing it in our technical specifications. If I picked up most of the technical specifications that exist by the different companies, right now they'll be absolutely silent on any of this, okay? So as our group, we'll need to work out a way of how do we include this? Is it included as a section for different systems, i.e. under emergency exit lighting section, do we then have a specific part on data collection? Or do we have a whole other specification, technical specification that we issue for all building services or for anything connected in the building? So there's some questions that we'll probably need to think about and how we're going to look at going to the industry with what we're proposing there. Next item. And then I've just pulled up a couple of other specs. There's a hydraulic spec and a mechanical services spec. You know, mechanical services is quite extensive. It's probably already covered a lot under BMS, but there are heaps of outliers that sections of the mechanical systems aren't connected to BMS systems, for example. So we need to make sure we're all encompassing everything that we can as part of what we're doing. So this is what I think we should be doing, especially consulting engineers. And you can even go back to if you're a Charter Hall or CBRE or anyone else, if you're getting a building built, you need to be enforcing this as well. You need to be going out to consultants and saying, how are we addressing data collection for this building? Who's doing what? Is it standardized, etc.? We also need to, as a group, identify different securities of data, because obviously we can't just send, say, access control security data out potentially because it's got a different security level to, say, a temperature sensor. And so we'll need to look at those sorts of issues. We need to make sure that the transport systems used by the data collectors into the data lake are also secure, and the security of those systems would also vary depending on what sort of data we're collecting and so on. And also, I just want to reinforce here, I'm not talking about any control here. I'm just talking about getting data out from these systems. Control is a whole different ballgame, and control can already be done separately through different APIs or anything else that can be agreed between maybe a lift control system and a fire alarm system or whatever. They can already do those controls independently. I'm just talking about one-way data collection. And then the whole idea is here we'd have a standard API for the building's data lake. So if you're BCA engineers, or say you're Chubb Fire Safety or Wormalds, you just have your own dashboards, your own smarts, and you plug it in to that data lake, and you instantly get everything that you want to see from the data. Okay, so we're trying to disconnect the people from having data sets in their own format just for their own use. We want to open up and say this is for the building. This data is owned and operated by the building manager for the building. So long term, the building's handed over at the end of construction, the data lake's set up, all the processes are set up, and it's up to the building owner manager to then pay for the upkeep of the data lake, whether that's an AWS or Google Cloud or whatever they've got on-premise data store, either way, but that's all part of running the building, okay? There's a couple of data models out there. There's that I think I'm not proposing anything at this point in time. I'm just making some of this stuff out there, putting it so everyone's aware that there is a whole bunch of things out there. There's one that I thought was quite good, was Fireware and smart data models, and they also refer to the next slide, which is it's which have specific protocols and data types that we can use as a reference, as an example. The big risk that we have is that we can't be too specific on certain protocols or data types, in the fact that it's always going to be ever evolving. So I've put forward Etsy today, but it could be someone else tomorrow, etc. What's important is that we have something that is generic enough that it fits in. If we're asking, as an example, for a fire extinguisher, we look at whether the pin's been pulled, whether it's been moved, whether there's pressure lost, the battery level. There's a few basic parameters, right? So that sort of thing is, we're listing that and saying we want this, and we may not even need to go into a huge amount of detail on the exact specifics of the protocol, but that's a data type that we want in that system. Okay, that's probably, I have some examples, but I don't think they'll work on. I can forward those JSON examples around. There's some data types that we've done in one of our projects. If anyone's interested, I can forward on the JSON files for you guys to look at. So I'm just going to now go out to the panel, and first of all, I'd like to introduce Goran from the City of Stonington, and maybe Goran, can you just give a bit of a background of your experience and challenges that you understand that's happening in the industry right now?
I've just stopped sharing. Goran, if you want to share your screen.
Beautiful. Look, I don't have actually anything specific to share, but thanks for introducing me, Nathan. I'm the smart city lead at City of Stonington. Previously, I was in the IT infrastructure team, and I've been working in IT infrastructure for a long time. But working in IT infrastructure, I had frequent. From time to time, we actually have requests coming from random people to connect solar panels, to connect the system to our network, and it was really unstructured and like without a process to connect the operational technology devices into the information technology. So now that I'm actually on the other side of the fence, in the more into that operational technology sort of space, I help internal teams in terms of what technologies we should actually use it in our council. So we've come up with a framework last year. We've actually established a framework. We call it Smart Facilities Framework, which basically outlines a little bit on a higher level than what you described in a very granular level, how to have the devices talking to one another. We basically had the framework to just outline like that open communication standards, like something that we didn't want the contractor of the day or the contractor of the month like to actually lock us into technology of the month, whatever is actually cheapest and whatever most accessible on the project. Because what we found was actually like a myriad of systems that we actually maintain across many of our buildings. So that is actually my experience and my involvement into these smart buildings on a much higher level. As I said, we identified 16 systems or 16 spaces that we actually want to have the interoperability. And it's a practical document that we wanted to share with our technology partners in how to determine what's the best technology for our buildings.
Yeah, thanks, Goran.
That's in a nutshell what my experience actually is with the smart buildings.
Yeah, no, I think that's why you've been selected as one of the panel members for contributing to this, given you represent a significant council, and a lot of our stuff we're focusing on buildings primarily, but outside the buildings, we have all the smart lighting, the street lighting, the car parking sensors, etc. So there's water metering. You guys have got a lot of other things environmentally going off. So I think a lot of those learnings will be quite useful coming into this buildings space. I'm just going to hand over now to Harman Singh from GHD. And Harman, if you could just introduce yourself and maybe give a bit of a background of some of your experience or issues and comments in relation to what we're doing.
Absolutely. Thank you, Nathan. Harman Singh, I'm the Smart Cities lead at GHD. Some people might know GHD. My elevator pitch about GHD, I call it the 90-10-1 company. A little over 90 years old, a little over 10,000 employees all over the world, and we are all working towards one common purpose, which is to create lasting community benefits. A bit of my background. So my story started, my professional at least, professional story started 22 years ago. So right out of the uni, which was in India, I did my bachelor's in engineering and stepped out to Dubai for my first job. And at that time, we wouldn't call it smart buildings, but basically what we were trying to do at that time was working with the startup to have a command and control center for more than 500 of Dubai's buildings, all being remotely monitored from this centralized location. And all we were doing was just picking up 10, 15 critical data points from every building. Fire alarm goes out, lifts go down, any air conditioning. You can't survive without air conditioning for too long in Dubai. But that was my early days. And I'll also mix the second part of the question along with my introduction, which is the challenges. So at that time, the challenge was lack of data. So 2 decades ago, we actually did not have enough data. We were struggling to get hold of. Whereas now it is abundance of data. We actually have more data than we can manage. So fast forward somewhere around 2010, 2011, and I had the chance to go to the US. So at that time, I spoke to one of the asset managers at the municipality. By the way, this time I was working for a building services company who were doing HVAC maintenance and BMSs and those kind of things. And this asset manager at a municipality, he said, every morning I get 200 alarms on my phone. I said, okay. So they had a portfolio of 100 or so buildings. So I said, what do you do with this 200 alarm? He says, nothing. I don't have time to actually tackle 200 alarms. So the challenge was abundance of data. If you can keep getting all these data from just different systems and all, at one point, it doesn't become any valuable. You're like, I can't do anything with it. Anyway, fast forward to my time at GHD. I was talking to a university, and Goran touched about this. The new challenge we are seeing today is what we call IT OT convergence. So, all those operational technology systems, the fire alarms, the public addresses, the video surveillance, security, BMS, lifts, all that is becoming IP enabled. And then the IT systems or IT teams are being asked to take over the management of those OT systems. Big opportunity, but big challenges. So this particular anecdote was the head of IT for a uni saying, "Hey Harman, what is this damn BMS systems that I've never heard about them? These guys are so outdated." I said, "No, the reality is BMS systems use those chips which have been discarded by IT a decade ago. But tell me, what is your problem?" And she said, "We are asked to manage all these systems and they are so lousy, we don't know how to control. So my team is finding a new ways to manage it." I said, "How?" "We are putting an IoT sensor in every classroom, the lecture theaters and all, and we are taking all that data to the cloud. And look at my phone." And the guy actually showed me, the technician, he says, "Hey, look, on my phone, I can see all those. And anytime the temperature or humidity levels are outside of the threshold, I get alerts." I said, "Wow, what do you do then?" So I get alerts. I said, "But then what else? What?" So he says, "No, now this is where the disconnect happens, because in order for me to take some action, I have to go to a different system, and those systems don't talk to each other." So I guess this whole IT, OT, the previous story about data abundance versus lack of data, I think they're all pointing towards a real big challenge. And that's the challenge Nathan pointed out, is we actually don't have really good standards. And good on you, Gordon. You're trying to do your best with developing those frameworks, but frameworks need to be progressed to a level wherein, if you are a building owner or an operator, you know exactly the standards that I need to request from my vendors. Otherwise, you get into that mode, vendor lock-ins. I'm sure you all have heard about that challenge too. So I'll take a pause. I've talked a little bit about myself, but a lot more about the challenges, Nathan. So to your point, and back to you.
Thanks, Harman. That was excellent, and we might circle back to some of that later. Wayne from AI Assets, would you like to just talk about what you're doing.
Will do. Thanks, Nathan. Yeah, so Wayne Herbert, the founder of AI Assets, a prop tech that focuses on digital asset registers for property and then lifecycle modelling off the back of the data that we capture. My background is actually a building consultant. So for about 30 odd years, been going around buildings, specialising purely in the asset capture, so condition audits, lifecycle models. And it was just so cumbersome, pen and paper, cameras, putting it all into Excel for days on end, working out the models off the back of it. Really an issue that industry had for years. So started to build a software for myself was the initial build, just to help me do my job more efficiently and take away some of the mind-numbing pain of doing it all. But when I got the first version of the copy, probably 7 or 8 years ago, I realised that it was actually solving a much bigger problem. So pivoted really from then to being the prop tech, to making it more commercialised. Worked on some big portfolios, both here in Australia, in the UK, Europe, Middle East. Over the years, such things as the Sydney Cricket Ground, the Opera House over here, and also Iconics. Been inside many a prison, hospital, school, you name it, any type of property, been around them and seen them all. But yeah, recently, so we launched the software a couple of years ago, and probably the biggest wins we've had so far and the biggest case study which relates into this, I think, is the Woolworths portfolio. For those obviously in Australia, we're all aware of Woolworths. For those, some here obviously over in the US and anyone else overseas watching, large retail chain for supermarkets, and they've also got liquor brands. So they had over 2,800 stores around Australia and New Zealand. They were using an old system, an IBM Maximo system, but it was 15 years old with, as you can imagine, data that was 15 years old. So they wanted to move to a new IoT type of model where they could scan to tag. Every time something broke, they had a help desk with like 100 odd people in there. Somebody rings up, it goes through the whole manual processes of doing that. So they wanted to scan to tag. So to do that, they needed a comprehensive asset register. They wanted a barcode on every single asset. And then using their phones, they can just scan it and log the work order. So basically they can get rid of pretty much all of that help center and be much more automated. So using our system, they managed to get around all of those stores, captured over 2.5 million assets in a 6-month time frame, which made it much more simplified and comprehensive. So that was photographs of every asset, all the major attributes like make, model, serial number, all of these things. And as I'm sure you'll be aware of, Nathan, when you're dealing with asset registers in a portfolio, there's usually several of them, if any at all. So the fireys will have one, the mechanical guys will have one, the HVAC guys will have one, all in different formats, different naming conventions, which sort of leads into this conversation well, because it's the lack of consistency. There is no consistency there. It's all in different areas. We're working with the Goodman Property Group at the moment. Again, they've got different trades, have got their different asset registers. So when they want to find something, they have to go through different formats to try and get something out. So there's no really smarts around it. So it's really about, in my world, it's about getting a centralized asset database for everything that's in there, and then being able to pick and pull from that, which then allows you to really get the data you need. And I think the future is really that collaboration piece. Everyone should be able to pull data from where they need to utilize it how they need. And for us, that works on like the asset registry, the lifecycle model side of things. If we can get the data from the BMS system or the sensors, that's going to greatly impact the knowledge about what that asset lifecycle is. And that's what we're working on in the AI fronts of things, is instead of just using industry standards of a light fitting last 20 years, that's when you replace it. We can be a lot more accurate on hours of usage, failure rates, all of these different things, location data. The AI smarts can be much more predictive on when you need to maintain the asset and when you need to replace the asset. So yes, that's really the areas that got me excited in this conversation.
No, absolutely. And the data is it's not just there for the contractors or trades. It could be there for anyone. It could be there for architects, for example. It could be exactly. Looking at a building to see how many times the door's been open and closed. Or, hey, that fire door's been used all the time. Maybe we need to put in some sort of cold open device on that door. Maybe we need to change the hardware more regularly because there's so much to data, but if we don't standardize it, as you said, we're just going to be on the back foot all the time. I'm just going to now pass over to Samir from Vantic. And Samir, you've been very patient. You can see that you've probably got the mouth to say something.
Now, both assumptions are correct, Nathan. I'm a very patient guy, and I have been frothing at the mouth to say something, but no, thanks for the opportunity. So just in terms of background, I've been in emerging tech. I'm based in Silicon Valley for the last decade and a half, and I've had a ringside view and been part of some companies that have not only achieved phenomenal growth, Harman, I think, to rival some of the work that you're doing in your company, but I've also been fortunate to meet a lot of people who are looking to solve real world problems. And sticking to the concept and the topic today, we at Vantic, just from a description perspective, we're an AI orchestration and real-time intelligence company. And I'll explain in a minute what that means. But we come at this problem from a slightly different perspective, right? Which is mostly in Silicon Valley, people are impatient in terms of solving problems, which is why you see so many ideas come out of here and some of them hit the mark. But in my experience and perspective, I really see smart building data's value being unlocked when real-time event-driven intelligence can replace passive data collection, right? And that's some of what you guys have been talking about on the panel as well, which is very heartening. And when this happens, you really transform buildings into adaptive ecosystems where there's enough intelligence coming out of the data in a building to make some actual meaningful strides when it comes to either efficiency in operations, even public safety for that matter, and so on and so forth. And I know we'll talk about a few examples a little later on in this conversation. But unlocking the real power in buildings doesn't only mean collecting data, it means to be able to act on it. And that's what Vantic really enables our customers to do. You talked about, or you asked Nathan, what is the biggest challenge that we're seeing in the interoperability space between data and buildings? Funny enough, the biggest challenge is also the biggest opportunity, right? And the fact of the matter is that the fragmentation of data across silos is really the biggest problem that we see. And that is, depending on which country you're in, steps are being taken everywhere, pretty much globally, to solve that. But the fact of the matter is that BMS systems or HVAC systems or even security cameras, IoT sensors, they're varied in terms of structure, ingestion of data, and therefore what they spit out. And there's no uniformity, as almost everyone on the panel has discussed. And that therein lies the opportunity, right? So the opportunity is to be able to shift from these siloed systems to an open event-driven architecture, which gets powered by a platform or technology that allows you to take actions in real time. I'll pick on an example I think Harman gave, which was, that's what, by the way, Nathan, got me frothing at the mouth when Harman gave me that example, which is this engineer looking at his or her phone with all these alarms going off and then them saying, I don't do anything with it, mostly because I got to go log into another system to take care of any of that. And the technology that we provide actually bridges that gap, which is and that's the AI part of the technology, which it reads the alarm, reads the thresholds, looks at false positives, and therefore either disables the alarm autonomously, or it actually, with a human in the loop, can tell you what to do next. And if you prefer not to have the human in the loop, it can actually take that action autonomously. I'll give you an example of one project that we were involved in, just to elucidate the point and then hand back over. But we did a SoftBank in Japan has their, what they call the crown jewel of their corporate buildings is in a port city called Takeshiba. And the challenge that they gave out was, we want to make this the smartest building in the entire SoftBank portfolio. And that involved solving some of the problems that you all are talking about, which is 1,300 sensors, 1,100 cameras, HVAC systems, all of this not talking to each other. That project was pretty intense and pretty interesting, but we basically implemented a solution that allowed all these systems to throw data out that we could ingest, and therefore build a platform and a capability that allowed real-time actions on HVAC systems. For example, if it gets too hot or too humid outside, why wait for a human to change that temperature, right? If it hits a certain threshold, the thermostat or the HVAC system should automatically be able to adjust. But what happens when the temperature then comes back to normal? Does your system adjust in real time to be able to go back to operating or going back to shutting off? Occupancy in conference rooms, etc. But I can talk more about that. But essentially, I think we come at it from the angle, which is where I started this conversation, is we come at it from an angle of, yes, of course, unified and uniform data is the way to go. And I think that's the future. But in the meantime, real world solutions need real world technology. And we come at it from a technology perspective.
So thanks, Samir. That's really good. I can't disagree with any of that. The live data and the impact that can have is immense. I'm going to talk about some of my own experiences with fire safety. We can be using temperature sensors from the BMS system as an example for positive reinforcement of a fire event in a building. Now, we have a lot of false alarms or smoke detection on the fire alarm systems. So just things like positive reinforcement. Should the fire brigade send extra vehicles? Is it just a false alarm again? Do they just send one, and so on? Yep, already across all of that. I don't know, Robin, have we got much time for any questions? I've probably been for a fair amount in our discussion.
Yeah, so there's a question in the chat, which maybe is worth going into, and then there are the other questions that we have for the panel, and I'll share my screen again in a second. But the question is, data or tech fragmentation across silo systems a consequence of the lack of executive or leadership or commercial team buy-in, or is it a lack of awareness? Probably also systemic. Hold on a second.
Okay, so that's open to all of us, that question?
Yeah, that's open to all of you.
Yeah, I'll do on that. Yeah, so I think it's probably a bit of both. It's a bit of the leadership, but it's in a way it's the awareness. Because in the asset registry world, there's so many different naming conventions that people use, and there's no sort of standard towards it. And Nathan, you probably know this. I'll give a fire, for example, in an asset registry, you can have it down as a carbon dioxide extinguisher. Others will call it 3.5 kilogram carbon dioxide extinguisher. Others will call it Firex 3.5 kilogram carbon dioxide extinguisher. CO2 extinguisher. The namings change so much, so I think it's the fragmentation, because there's so many different sort of standards. You've got VBIS is a new one that's came out over here a few years back, and then you've got your different ones coming out of the States and the different regions. People tend to use different naming conventions, so yeah, I think it's the awareness of which is the best standard, and then the decision by the leaders on which one to use. And really, it's really down to the industry. We need to change that to make it simplistic. We need to make it simplistic from the top to the bottom. So your engineers, I know VBIS was built by a set of engineers. Doesn't really translate when you come down to asset managers and maintenance providers, because you've got different naming. They use a typical 4-tier structure, but some of the assets only have 2 tiers. There's codes you can use with it as well. But when you're like, say, a maintenance guy, you just need to know it's a chiller and what type of chiller. You don't need to go through all this coding language. We really need to get, and to me, that's where a data lake would come into it, that you could pick one name and then you could say which convention you're using, and it will automatically convert it for you. So depending on whether you want to use 15-digit codes or you want to call it a very simple carbon dioxide extinguisher, it's open for all.
Yeah, so thanks for that. I'm just going to add my comments to this. I've been in the industry for a long time, and I can tell you right now that some of the biggest challenges have always been there, and they are the big companies. They are Honeywells, they're Snyder's. These guys, all of their systems that they made, their BMS systems, lift control systems, they've all come from a point of time where they want to complete control domination of that building. Okay. And building services engineers have just gone with it. Everyone's gone with it and said, okay, connect to the BMS system, connect this there, connect that there. And it's really, if we're going to change this, we have to confront it head on. And the engineers, people in all these organizations and through leadership, right at the top of all the engineering businesses who are even specifying buildings, architects as well. Architects need to be educated on this. Okay, so we're right at the front of this. We should be saying straight away, what are we doing about data on this building? People just say, oh, we got a BMS system. That's rubbish. This is the 21st century, right? We need to have people who are strong leaders, and these need to go down through the company, so that when you've got an electrical engineer or someone in the meeting or discussing this, that they've got the confidence to even understand what we're talking about. Because a lot of what I find is there's a huge skills gap between people like myself and Harman in our big organisations to then going down to the electrical engineer just writing a specification, or a project engineer who's just trying to get the job done. It's not his mindset to go and start even thinking about this. So it needs to be driven through the companies and right from all the way through the building construction industry. So if you're a builder, they need to be educated on this as well. So that's part of our challenge. There's no point producing a specification and what as a forum between ourselves if no one's going to adopt it. So this requires significant key people involved to actually drive it further in Australia. Yeah. Sorry, Goran?
I was actually going to say, Samir basically sort of mentioned that fragmentation depends on the country. And you nailed it. Fragmentation actually starts from the proprietary development by the Schneiders and Honeywells and everything. That then we as a users, and I'm actually talking we as a Royal, we local councils managing billions of dollars of buildings and assets, we then end up into managing these systems. And there's actually such a big disparity between what the challenge we're actually facing is basically needing to maintain that knowledge or the resources and how to actually manage these internal systems that are actually getting outdated on a daily basis. Then the question is, you mentioned, like, how do we actually get away from this? Do we just create standards, or we just actually wait for a new company to come along to create like an open standard that is actually going to take everyone and every building actually slowly? And I actually see some examples coming out of from Europe in building management that we're like trying not to sort of to play with. But there is also actually in smart lighting, for example, there is a company called Zen Control, which is from Queensland. That one, for example, was managed, sort of to do like a good platform where it's a cloud platform, easy for consumers, to understand, but also actually loved by the electrician and lighting specialists. Is that maybe the way and the approach to make sure that interoperability is actually key in every building that we actually build? And that's actually where our framework was actually facing, was actually focusing on, was actually exactly that interoperability. Our document actually doesn't say you must use Modbus or this other protocols. It just actually says, well, whatever you do, the lifts and the fire panels and everything else must actually sort of talk to the BMS system. So yes, the interoperability is a challenge, but it's actually a challenge from the total cost of ownership and, as I said, resources.
Yeah, no, I agree. Should we probably go to another question, or does someone else have any more comments to that one?
I think one more on there is, as well as the tech companies, we need to be more open to sharing data. A lot of the tech companies they see it as their data, so they don't want to share it with other companies, especially some of the big ones. Looking in the property space like Yardies and MRIs, I know Yardi is quite a closed ecosystem, whereas MRI are a bit more modern thinking and open to collaboration. So I think that's a lot of the problem as well. They see it as their IP and their competitive advantage. And so I think that needs to be addressed probably first and foremost, to be honest, of sharing data.
Yeah. This is the next question that we've got posted up at the moment. Tell us about a use case or project that has set an example for interoperability, interconnectivity, or collaboration between vendors. I can kick this off just briefly. I've had one where I've had to basically connect Legrand's data to our fire extinguisher data to one common dashboard. So to do that, we've had to standardize the data produced from these two different systems, two different companies, two different systems. So that's one of my most recent experiences, but I don't know if anyone else adds
Yeah. Nathan, I can definitely add to that. I brought this up real quick when I was giving my long-winded introduction for some reason, but I think it fits better here. So we face this pretty much all the time with the smart city projects that we get involved with. The example, and you can feel free to Google it, there's more detail there, but the SoftBank headquarters in the port city of Takashiba, I think the challenge that they put out there was that they were building the state-of-the-art building, but what would it take for the building to be really smart? And therefore, why could they call it a smart building? So essentially what we ended up doing was we ended up integrating about 1,300 sensors and 19 different technologies via the platform to do the following. And some of the use cases that came up were really new. And this was about 2 years ago, and we've done more projects since. But essentially what we did was we gave them real-time HVAC and energy optimization. I spoke about that example as to how We could control sensors to shut off air conditioning in some spaces based on occupancy, or restart air conditioning when someone walked into a room, or sync with calendars, for example, on email platforms to read when that room or those particular rooms were booked for meetings and switch systems on 3 minutes or 4 minutes before the meeting started, so on and so forth. So that's one example. The second example is, and I think, Nathan, you alluded to this, which is AI-enabled evacuation protocols. We work with, believe it or not, sensors in their exit signs that they were putting up, where in the case of a fire drill or in the case of a real-world mishap, it would actually guide people through a smartphone app for the building on evacuation routes and which was the quickest way to get out. And then the third one that kind of comes to mind is we used videography or video images for access control. And this kind of leaked into a public safety use case as well. Picture a situation where you have an unwanted occupant in a building, God forbid, armed and ready to do harm. Real-time sensors would actually catch that image and then relay that image back to the platform that would then take action of shutting down access to some sensitive areas or highly populated areas of the building so that the individual could not go there. But it doesn't stop at that. It then interacts with emergency systems and building security systems to be able to alert and send that video feed directly to security personnel so they know exactly where the individual is and can correct or remedy the situation with minimum damage, God forbid. So I think that's a great example of working with just HVAC systems, BMS systems, videos, IoT sensors, so on and so forth. And then the other example that I think the world was talking about a year ago, and then they got tired of talking about it because a lot of innovation tends to come out of the Middle East these days, especially in cities like Abu Dhabi, Dubai, Qatar, so on and so forth. And there's a financial district that they've built there with 11,000 cameras and IoT sensors for heating and cooling. And this goes back to Herman's example of someone having to manually run around, control this through a control center. So we built them a command center that could actually monitor temperature in real time. So it was ingesting weather data, it was ingesting HVAC data, and taking real-time action. But those are the kind of two examples that come to mind.
Oh, that's great. I don't know if we got one more. Have we got time for another question, Robin, or have we out of time?
Just because there's one that follows up for Samir, are use cases dictated by clients or offered by providers?
So the short answer to that is usually we're the ones that offer these use cases because a lot of times, especially again, by default sitting in Silicon Valley, a lot of time technology is brand new and the world hasn't seen it yet. A lot of the use cases that I'm talking about, one was actually offered by us as a public safety solution and then ballooned into this other piece. But the smart city one for SoftBank specifically was dictated by the client and what they wanted to see in terms of a smart building. But it was driven by the problem that we're all talking about, which is systems not talking to each other and data sitting in silos and fragments.
Yeah. So perhaps what we do then, Nathan, because we are running short on time, but we do, of course, always want use cases and we can collect those and publish them afterwards, the show notes, is just look at the final piece of all of this and the final two questions, but which really were around what needs to happen so that in a year we don't regroup with the same problems. So what do the next 12 months need to look like and what will it take to really make buildings smart in this context? So maybe we go around and do a closing comment like that. I'll hand back to you there.
Okay, well, I'll kick it off. I've been tasked as the chair of this monumental task, but in saying that, I do have a lot of resources at my disposal, and so I feel I can drive some of this, but I definitely am going to need significant support from the industry. And I think the first thing that we need to be looking at is assembling or trying to break down some of the tasks to some specific people. And those people will no doubt include the ones that are in this meeting, but potentially others as well. So we'll be seeking engagement with manufacturers, and whether they're Snyder's, Honeywell's, fire alarm panel manufacturers, whatever, we'll need to go out and engage with each of these parties to understand whether they'll be open to this and what sort of data we can even collect from their systems, as an example, and then try and come up with a framework for I think within a year, just on what types of data that we should be collecting from different systems, and having that idea of every building having a data lake. So I think it's baby steps, but just having that conversation and something that we can say, this is a guideline that we're up to right now in terms of collecting data and storing data. I think that's where we need to be in a year. We're not going to have, it's probably not going to be hugely comprehensive by then, but I think we could have made a good start.
Amazing. Do you want to just go from the top of the screen? Samir, you're at the top for me.
Look, I think there's 3 or 4 things that come to mind. One is obviously a unified, almost semantic data layer needs to happen to make this secure. You've got to have, we've talked about this, open API standards, especially with so much technology that runs on APIs today. Those standards need to be open and they need to be secure. I also feel like federated architecture is something we encounter a lot, or the lack of, we encounter a lot in some of the projects that we do. And then Nathan's brought this up, certification and oversight and governance. Having standards is great, but if those standards are not enforced, it's another good to have. And the world isn't going to wait in the meantime, because technology, the only piece I want to make, just bias out of sitting out of Silicon Valley, is technology is just developing and galloping at such a pace that I think some of these standards aren't keeping up. I think there needs to be more real-time action when it comes to these governance standards, et cetera. So I think we're off to a good start, though.
Carmen, you're next for me.
I'll keep it short and brief to build upon Nathan and Samir, especially the last point from Samir. We need to take action. It's a problem worth solving. My key point is speed is going to be the determinant of success. So companies who can take action at a quick speed will definitely be leaders in this space. So wherever we are, we should think of taking action, but doing it right away, quickly, to jump onto it, do your frameworks. And as a team, Nathan, I'm willing to support you, whatever I can do with my 2 cents of knowledge. Yeah, be happy to be part of the team to build up that specification that becomes the framework for smart buildings.
Excellent.
Wayne?
I think the guys have covered most of it. I think that probably 2 areas I see are quite key is obviously the collaboration point. We need the collaboration. We need some of the big players to jump in. And I think ultimately the owners as well, big owners, because the data all comes down to them. They're the ones that should own the data at the end of the day. It shouldn't be with their service providers or the building managers, which swap every 5 to 10 years. It should be theirs. So I think that's a big one. And then the other thing is simplicity as well. Whatever we build out needs to be simple that everybody can follow. We see so many times it gets complex and we get really in, you can look at so many standards and you need a degree to understand them. So I think for everybody's buy-in, it's got to be something very simple. So yeah, that's my sort of points.
Love it. Grant, do you want to close us off? How do we drive forward?
Let me fish out the unmute button. Look here, just to echo on everything what this panel actually said. In my mind, whatever we should do needs to be a content which is going to be easy to understand for non-technical people as well. Yeah. Again, I'm actually looking from the local council perspective where...
Is it just me or is Grant's audio?
Oh, it seems okay now for me.
Is it okay? Can you guys hear it?
Yeah.
Oh, it just as we need to be able to propagate fast these requirements, these learnings, which actually brings me to the next point, which is the scalability. It needs to actually be easily implementable across many. Again, I'm actually looking from the local government perspective. We all share common problem, sometimes joint problems. But if we can actually scale, make this uniform sort of approach, we can actually replicate very easily across many other local government authorities. And also, actually, I would like to again go back to that initial thought about that crossing that gap between information technology and operational technology. It seems to be that information technology is by convenience or by, I don't know, the availability currently in our organizations, the main arbiter of the technology. But we need to actually build that operational technology space, which is like a separate sort of, but very complementing aspect of the technology within the organizations. That's my 2 cents.
Yeah, absolutely. I've just got one more comment. I think the most important thing right now is the concept of a data lake for the building. Okay, I don't think people are thinking about this in that regard. Everyone's thinking about just getting the data for their own purpose. Okay, we're talking about a data lake for a building, okay, which is open for other people to look at, depending on who we give access to look at that building. Really important, and that concept is probably something that we all need to do, everyone involved in this meeting, to start, whoever they're engaging with, they should be bringing it up straight away. Where is a data lake for this building? What data do you want, etc., because no one's having it. I can say right now, there's no discussion about it. Most of our project meetings, whether it's a 4-story little office building or a nursing home or there's so many things that we're working on, and it's not even brought up. So that's my final comments from today. And I'm really hoping together as a team that we can get some traction and really be the leaders in the industry for this.
Perfect ending, Nathan. So that's exactly what this is. We will do a write-up post-webinar and share any notes that you've all highlighted already. And if you do have any links to those use cases or frameworks that you've mentioned, please pop them over so I can share them with any registered participants. There are about 80 people that registered to receive the recording, which is really good. So that's our initial cohort that we'll be putting this out to. But the next step is exactly that. Join us and join in as we flesh out this task force and the working group streams or fall within it and look at how we can then shape up a guiding framework or specification and what that rollout might look like as we take it to market. And we put out a call to different industry bodies as well to participate and support it. So with that, I'll close us off and say thank you so much for joining us, and thank you to our speakers and to Nathan for hosting. If you do have any questions, please feel free to reach out via email or LinkedIn when we get the recording out, and we're looking forward to having lots of participants in these working groups. Thank you so much.
Thank you.
Yeah, see you later.
Thanks all.